right, so welcome to part 2 of chapter 5. So we had just finished talking about absolute threshold and difference thresholds. And so now we're going to transition to talking about sensory adaptation, which is it's a similar concept. It essentially allows us to dismiss some constant information in our environment. Because the truth is that in any given second, we are receiving a lot of information from a lot of different places, and some of it's just not very important. So, for example, the pressure that you feel from wearing your watch on your wrist or your glasses on your face or a ring on your finger, that's not important information for us to get. And so the first couple of days or maybe even the first couple of weeks that you wear glasses, you're probably not used to them. And so that's new, important information. And so we're constantly receiving that information and perceiving that there's something on our face. But eventually, at a certain point, we just adapt to that sensory information and don't even notice it anymore. So those of you that, wear something like that every single day, you probably don't even notice anymore. The reason that is because the nerve cells temporarily stop responding to that pressure or the presence of that stimulus, which allows us to kind of dismiss this unimportant information and then allows us to attune to more important things. Which brings me to the next concept is this idea that we are getting a lot of information at any given time and we cannot attune to all of it all at once. And so that's why we do have sensory adaptation, is because we need to try to kind of disregard things that are less important. But sometimes we actually miss things that are important. So this can be referred to as selective attention. And I know that that's a concept that we throw around a lot in everyday life. I know that, my father's hearing isn't very good. And so my mom always teases him, well, he can hear fine. It's just selective hearing, meaning that he's kind of consciously deciding what to not listen to. And of course, she's referring to the fact that he doesn't listen to her. So what we mean by selective attention is that we are often going to miss information because we are focusing on one or two or just a handful of more important things. So when you're taking a test, you probably rely on selective attention to actually focus on the more important thing at that moment, which is doing well in your test or your exam, and you can kind of disregard the person next to you tapping their pencil or now that you're doing a lot of your work at home, maybe dismiss the dog barking in the background or your little brother watching TV. And so selective attention actually is kind of a protective or a good thing because it keeps us from being overwhelmed with sensations. But the problem is that often this can lead to inattentional blindness, which is where we actually fail to consciously register an object that we're looking right at or is very easily or should be perceived. And so the famous gorilla example, with the basketball players passing the basketball and you're told to count the number of passes. And you're so focused on that one thing that you miss the big 8-foot gorilla, walking through the center of the screen. And so inattentional blindness can be problematic. It's a hazard of selective attention because, selective attention is a good thing because it keeps us from being overwhelmed with all the sensory input we're receiving. But inattentional blindness can be problematic because we're failing to perceive something that is just so obviously right in front of us. And so this can be problematic in situations where, kind of famously people have witnessed crimes happen and didn't even see it or didn't get enough important information to then, help the police locate who it is or be a witness in the trial. And so this relates to kind of a similar form of selective attention, which is called change blindness, which is where a change occurs right in front of us, but we don't even notice. And so I put the YouTube clip there. There's this kind of famous study that happened on a college campus where there was an individual, this is a research assistant, this person's pretending to be lost. And so they're standing there with a map and they're looking around and they look very confused. And so they approach this person and ask the person for directions. And so notice what's going to happen is two people are going to walk through these, the individuals on the screen, and one of the people is going to switch out. So you can see the person's asking for directions. This very nice woman is helping him. These people walk through. This is planned, and the guy switches, and then she continues talking to this completely different person and doesn't even notice. And so they repeated this experiment over and over and over. And what they showed was about half of the time, people did not notice the change. That they were talking to person A and then just unexpectedly were talking to a completely different person. And so what we're talking about is sensing without perceiving. You're looking at that person's face, you're receiving enough sensory information to know it's not the same person, but you don't perceive the change. So as I mentioned when I started this chapter, I'm not going to get into the weeds and talk about, the different anatomy parts of the sensory organs or the different processes in the body. So for example, the different components of the eye or the ear or the tongue. Please read that part of your book, know that part. It is very important. I'm going to stick here more to kind of the perceptual part of that process. So we talk about Gestalt principles, which are essentially this theory that helps us understand how our brain organizes the sensory information. So as I said early on in this chapter, our sensory information is basically meaningless until we assign meaning. And so the Gestalt principles help us understand some of the ways our brain can assign meaning to visual information we get. So the first one is figure and ground, which is essentially the idea that when we look at something visually, we have to determine what is the background and what is the object, and then that helps us try to determine what we're looking at. Proximity means that we group things that are close together, and then that has some kind of meaningful unit to it. Closure means that any gap in an object we're looking at is going to be perceived as a complete form. Similarity basically means we look at things and anything that is perceived as being similar in color or shape is going to be grouped and assumed to belong together. And continuity is any lines or patterns are going to be assumed to continue in time and space. So again, just to kind of go through a few examples here, when you look at something visually, the first thing your eye tries to do is determine, okay, what is the thing I'm looking at? Because this whole picture is kind of the same color. But within a matter of a second or so, you were able to recognize that there is a spider here. So you identified this is the figure and the background is the ground. And so based on that Gestalt principle, you were able to perceive that there's a spider in the picture. Proximity. So again, things that are grouped together will be perceived as going together. So essentially the same number of dots are here on the left as are here on the right, but we perceive this group of dots as one group, these as three groups because they are closer together. So these two columns are closer, these two columns closer, these two columns closer, which means we perceive this as three groupings of dots, and this is a single grouping of dots. As I said, any gap is kind of closed in and perceived as an object. So we, can kind of see that this is a triangle here, even though it really is just the absence of anything. And so we're going to close in this space and we would perceive a triangle on top of circles. And so we kind of close in anything that's missing and perceive an object. So here we see that these objects are similar, and we can see these objects here and up here and up here are similar. And so we perceive that there is a triangle of triangles because these objects are perceived as similar. Continuity, so rather than seeing a bunch of half moons or half circles, we see a line with a squiggly line continued over it, because rather than seeing objects or individual pieces here, we see continuity, meaning that it's a continuous object over time and space. So those are just some of the principles that we use visually to receive sensory information. Again, your book goes through in great detail how that sensory process occurs, and here I'm focusing more on the perception piece. So another thing we do visually, if we have to infer distance and depth. So when we are looking around, one of the most important visual perception processes we go through is figuring out how far away things are and what the depth of those objects are. And so we have two different types of cues that we use to do that. The first is binocular, meaning using both eyes, and the second is monocular, using one of our eyes. And so using two of our eyes, we're going to use kind of two similar processes or kind of complementary processes. One is convergence and the other is retinal disparity. And so by convergence, Essentially, the degree to which we turn our eyes inward gives us information about how close that object is. The more our eyes have to converge, tells us the object's closer to us. Retinal disparity, on the other hand, is where there's a slight difference in lateral separation between objects as seen by our left and right eye, meaning we're receiving perceptual information from both of our eyes, and depending on the lateral separation that's perceived, we then can try to determine things such as distance and depth. The monocular, on the other hand, again, are going to use one of our eyes. So something like interposition, for example, we're going to try to determine are objects partially blocking each other, or is one object obscured by another object, and based on our perception of that, we can try to determine what objects are closer versus further. So I think the easiest example of this is looking at a skyline. If one building is partially blocking another building, we know that that first building is closer than the other building. Linear perspective relies on parallel lines. So looking at this footpath going away, we can see that the the edges of the path look like they converge, but our brain knows that they're parallel lines, right? This path doesn't get more narrow as it goes, it stays the same. But because they appear like they are converging, we can then convey or can then perceive depth based on how quickly those lines are perceived to converge. We use clarity to try to determine how something is how far away something is. So I think about going to Shenandoah National Park and pulling over one of those overlooks and looking out, and we know that there's particles in the air, and so objects that are perceived as hazier or duller or less detailed as we look out from that overlook are perceived as further away. So you can kind of see it gets hazier further out. This closer mountain is perceived with more clarity. We also use the relative size in our visual field of objects to determine how far away they are. So this runner right here looks much bigger than the runner over here, but our brain knows that these runners are probably similar in size, right? That there's not that big of a difference in these runners. And so our brain is able to use that sensory input to perceive how much further these runners over here are from the runners that are perceived as larger. Texture gradient also helps us try to determine how far away things are. So here you can see the sunflowers are perceived, the sensory information coming in looks as if these sunflowers are further apart, then they get more narrow, and then they're very much on top of each other way out here. But our brain knows that the rows of flowers are probably similarly spaced out the whole way through the field, and so the elements that seem closer together are just going to be perceived as further away. So light and shadow can also help us determine the depth of something. So as you can see, as the circle over here on the right kind of changed color from this kind of flat singular color to having different shadows and different textures of light on it, we now perceive it as a three-dimensional object. And so that is something that artists rely heavily on when painting to try to convey that something has three dimensions rather than being just a flat singular dimension object in a painting. The motion parallax is really cool. So I think the easiest way to think about this is if you're like in a car or on a train. So when an observer is moving, the objects outside the window actually might appear that they're moving at different speeds or even in different directions. The closer the object is, the faster it seems to be moving. The further away, objects might, seem like they're moving slower. And so it's this idea that perceptually, information that's further out and is in motion is going to be traveling at a different speed in our perceptual field than something that's closer, which again might even appear that it's moving backwards. And so that is information that our brain knows how to process and can help us look out and say, wow, that mountain's really far away. It doesn't look like it's moving. Or if you've ever had that experience where like the telephone poles look like they're moving in the opposite direction, again, that's visual information your brain knows what to do with and can help us try to determine where our body is in comparison to other objects and understand the motion or lack of motion of those objects.